This is kind of a multiplex explanation of gravity and planet formation, which is a byproduct of the same thing. But let's pretend the water in the bowl is space and the sand is the medium floating around in space. Now, when you create a disturbance in space, like our sun does, it spins and it creates basically like the eye of a tornado, right? That's why all galaxies and everything look the same. They always have an eye in the center and they have the spiral shape. It's the same reason that my bowl does what it does. Now watch. You would think that all of the material would sling outward centrifugally, but actually, if you spin this water, you create the same warp in space that a planet does. Watch what happens. All of the material, the dense material, accumulates at the center first. Now, if you noticed, there was a double wave formation in the water as it was spinning. It goes out and in. They cross over each other. It creates an eye of least resistance in the middle. Now, the reason that matter wants to go towards that central eye, or anything with any density, is because anything that's denser than the water, is because out here it's turbulent. You have these waves going this way and this way. They're slapping across each other. In the central eye, it's the place where everything equals out. It's the place where there is the least amount of resistance. And matter naturally wants to go towards that. It's because of the warp in space-time. Now, space-time is this water right here in our little experiment. Now, that's the reason that the center of our planet, which was probably, let's say it was a chunk of the sun that flew off and it was spinning, because the sun flings things off in a spinning fashion because it's also spinning, right? Let's say it broke away and spun. Our core was hot. Now, it attracted a bunch of, basically like this, you have your core that was the most dense material that's hot and spinning. It actually disrupts the medium of space into a cone or a vortex, whatever you want to call it, just like a tornado. It creates this central eye of least resistance, and then matter starts to attach to that because everything that's dense enough, denser than space, wants to go towards that eye of least resistance. Now, eventually, over this chunk of sun that was spinning, dirt started to accumulate, and pieces and particles from space and things from all over started to draw towards that eye and create what we know as our soil. Now, that's also a combination of magma and that hot core spewing forth, and mixing with things, among other things. But that's essentially what happens, is the dirt and everything that we call soil and our crust accumulated on the outside. It's also far enough away from the central heat source that the cold space allows it to solidify, right? So that's another part of it. Also, it's far enough away from the heat source, but still close enough to the heat source that we can have liquid water. The sun also helps that big time. Now, this is the same way a sun works. A sun is the central eye of least resistance. It's the dense material in the center. But I think, or some people would argue, that the sun is the actual thing that caused the stir in the first place. And to me, it seems that suns are kind of an output situation and black holes are kind of an input situation. So I'm thinking that probably our sun is the output side of some form of massive quantum entangled particle situation where there's an intake and an output. Now, I'm not saying black holes feed suns, but it's very possible. Anyways, that's a basic explanation of what gravity is, all right, and what forms planets. Now, let's say you and I, we're little humans, right? We have density. We're more dense than space, just like that sand is more dense than the water. And we also want to attract towards that eye of least resistance in the center, because all this turbulent wave patterns that are beating us towards the center, essentially, right here, all forces equal out. Push and pull equal and make zero. That's your 0 point. And that's why we are attracted to that. If you put a ball of solid crust around this little eye and you put a little human in this water, they would go to the crust. And the faster it spins, the more they would sling it. The human would be a little lighter. The slower it spins, the more they would be attracted to the center crust, right? So if the Earth slowed down, you would actually be a little heavier. If the Earth sped up, you'd be a little lighter. because it would be centrifugally slinging you away from the eye more. Now, if it all stops completely, like my bowl's doing, eventually there won't be anything keeping the material in the center anymore. So that's what's going to happen to planets and suns and everything. It works exactly the same way. Now, if you want to say this is the sun in the middle, it's the eye of least resistance. That's our sun. Our planets are also attracted to the sun the same way our bodies are attracted to our planets, right? Our Earth. Our planets are also stuck in between being centrifugally slung outward, all right, and pulled inward towards the eye of least resistance. And I think they call that centrifugal and centripetal, I believe. But anyway, that's the basic explanation. That's why we have gravity. That's why the planets are attracted to the sun, because they're caught in between outward and inward sling. They're trying to go towards that center. The sun is rotating slowly enough that the planets are actually able to sling outward centrifugally and resist the pull towards the center, so to speak. If the sun were to speed up, I think it might create more pull towards the center. Or if the sun were to slow down, it might allow us to drift away from it, you know, something like that. It might be almost the counter of what we think would happen. Anyway, there's a basic explanation of what gravity is and how planets form and how suns affect planets.